Advanced Course, Episode 3. LangGraph is the tool that turns a simple agent into a real system. States, branches, loops, and human approval checkpoints. If you build agents seriously, this is the most important episode in the entire course. Let's go. Welcome to Episode 3. LangChain's basic agent runs in a straight line. Input goes in, a sequence of steps runs, output comes out. That model is fine for simple tasks. It fails the moment your workflow needs to branch, loop, or wait. Think about a real research and writing workflow. First, the agent researches. Then it decides, do I have enough information? If not, it loops back and researches more. If yes, it drafts. Then a quality check runs. If the draft is poor, it revises. If it passes, it publishes. That workflow is a graph, not a chain. LangGraph gives you graphs, and graphs are the right data structure for real agent workflows. The core concept in LangGraph is the state graph. You define a Python typed dict that holds your entire workflow state. Every node in the graph reads from the shared state and writes updates back to it. LangGraph merges the updates automatically. This is fundamentally different from a chain, where each step only sees its own input and output. With shared state, any node can access anything that has happened before it. The writer node can read the researcher's raw findings. The quality checker can compare the final draft against the original user request. Everything is visible, everything is trackable, and when something goes wrong, you can inspect the state at any point to understand exactly what happened. Nodes are Python functions. They accept the current state as a type dict and return a dictionary of state updates. You register them with the graph using the add node method. Edges connect nodes. A normal edge is unconditional. After node A, always run node B. A conditional edge routes to different nodes based on a function that reads the current state. This routing function is where the intelligence of the workflow lives. Here is a concrete example. After a drafting node runs, your routing function checks the state for a quality flag. If quality is below threshold, route to the revision node. If quality passes, route to the publish node. The graph handles all of this automatically based on state. And here is the feature that changes everything about how you can build human in the loop checkpoints. You can interrupt any node in the graph. When the graph hits an interrupt, it stops, serializes its entire current state to a persistent checkpoint, and waits. A human can then inspect the work, read the current state, provide feedback, modify the state if needed, and resume the graph from exactly where it stopped. The graph picks up with the human's input incorporated into the state. This is not a workaround. It is a first-class feature of LangGraph. Checkpoints are stored in SQLite by default, 0 configuration required. The workflow survives process restarts. You can start a workflow on Monday, get a human approval on Wednesday, and the graph resumes as if nothing interrupted it. This combination, shared state plus conditional routing plus persistent checkpoints, lets you build agent workflows that can run for hours or days, involve human review at key steps, and recover from any interruption gracefully. Here is a complete 3-node researcher, analyst, writer pipeline with a human approval gate. First, define the state typed dict. It holds the original research query, a raw finding string, a structured analysis string, a final draft string, and a human feedback string that starts empty. Then write 3 node functions. The researcher node takes the query from state, calls a web search tool, and returns an update to raw findings with the results. The analyst node takes raw findings, passes them to the LLM with a prompt to extract key insights, and returns an update to structured.analysis. The writer node takes the query and structured.analysis, generates a full draft, and returns an update to final draft. Then add a 4th node, human review. This node uses LangGraph's interrupt function. It takes the current draft from state, formats it as a review request, and calls interrupt with that content. Execution stops here. The human sees the draft and can either approve or provide specific revision notes. When they respond, the graph resumes with their response stored in human feedback. Add a routing function. It checks the human feedback field. If it contains the word approve, route to done. If it contains anything else, route back to the writer node, passing the feedback as context so the writer can revise accordingly. Build the graph. Add all 4 nodes. Add a conditional edge from the human review node using the routing function, and compile. Run the graph with a starting state that has your research query. Watch it flow through researcher, analyst, writer, stop for your review, then complete or revise based on your feedback. The full working implementation is under 90 lines of Python. Once you see how it clicks together, you will want to put everything in a graph. Your challenge: build a 2-node fact checker workflow. Node 1 is the writer, generates a draft on any topic you provide. Node 2 is the fact checker, uses the LLM to identify any claims in the draft that could be factually incorrect and flags them with a confidence score. Add a human interrupt after the fact checker. Review the flagged claims before approving publication. Try it on a topic with historical details or statistics. See what the system catches. That is LangGraph. You can now build workflows that think, branch, loop, and wait for human judgment before they proceed. Episode 4 is where it gets serious. Production, evals, monitoring, red teaming. How do you actually know if your AI works? See you there.